study here. Here's another example of where we're going to use quadratic functions to solve an application problem. So in this problem, we've got a project, right? So let's say I'm a construction owner. I own a construction company, a development company, and we want to build a parking lot here, okay? Let's say we're going to be building a shopping center, right? Could be Woodman's or something, right? And we want a parking lot, right? Let's say this is just a standalone parking lot, who knows? Or maybe this is a parking lot for shuttles to the airport, right? And so that actually makes more sense when you hear what I have to say. So anyway, so let's say we have this parking lot, and we're going to we got parking spots, and we want to maximize the area, right? We want it to fit as many parking spots as possible, right? And so we've got only so many feet of fencing, right? We want to fence in the parking lot. Obviously, we don't want to fence this side. At least in this problem, they don't want us to. But assume that we're not going to fence in the side that's adjacent to the road. Okay. So we've only got so much fencing, right? Linear feet of fencing, and we want to fence in. We want to use all the fencing. And maximize the area, right? So in this case here, we only have 340 feet. So 340 linear feet of fencing. Okay, so we want to use all 340 feet, no more, no less, and we want the dimensions of the parking lot to be such that the area is maximized. All right, so how do we do this? Okay, so we've got to use area. So let's first find our function for area that involves the dimensions given. So we know that this dimension is x, this dimension y, and we know that we have a rectangular shape, a rectangular parking lot. All right, so now, what is area? Area is what? Length times width. So length times width, or base times height, however you want to look at it. But we got to multiply these dimensions, okay? So that means area, so area and, how do we want to do this? Do they give us anything else? Yeah, area. Yeah, so area is equal to, I'm just saying area, area is equal to x times y, right? Okay, so now, well, we need another equation though, right? Because right now we've got one equation, area, but we got two variables, two unknowns. So we're going to need another formula to get rid of one of these unknowns, because we've got to have this in terms of one variable. So let's use the 340 feet of fencing and use another measurement, which is perimeter. So the perimeter minus the road, right? So we're going to take the length of these three sides, and we know that the length of these three sides added together must be equal to 340 feet. All right, so let's use that. So we know that what? It's going to be 2x, because there's two sides here, plus the third side, y, must equal 340. All right, so there's our other equation. So now let's solve for y. Okay, so y equals negative 2x plus 340, which now we can go ahead and substitute this into this, which is going to give us x times what? Negative 2x plus 340. And now, if we distribute the x, we get negative 2x squared minus, oh no, plus, sorry, plus 340x. Okay? And now we have our area, which now I'm going to represent it as a function, which I'll use capital A for area, but it's area a function of the length of x. All right, now we can solve this to maximize the area. So where does the maximum area occur? Well, remember, this is a parabola. It's a quadratic function, so this is a parabola. The parabola opens downward, so the maximum area is going to happen at the vertex, right? So that means all we have to do is find the value of the vertex using the vertex formula. So in this case here, the vertex is going to be x equals negative b over 2a. Okay, so we're what? b is 340. So it's going to be negative 340 divided by 2a, which is negative 2. And this should make sense because right away you want to think, okay, x has to be positive, right? Can't have a negative length, right? So that means this negative cancels. So this is good because we got two negatives that cancel. So this is going to be positive. So right away, I'm good. I feel good about the answer. Okay? So this is going to be 340 divided by 4. Okay. So this is going to give us 85, I believe. 85 feet. Why feet? Because that's the units that they gave us for length. Yeah, so 4 times 80 is 320 plus 20 gives us 340. So 85 feet. Okay, so now here's the thing. So that's not the answer we're looking for. They want what's the maximum length. Let me look at this again, just make sure. It says determine the dimensions of the lot that would maximize the area. So now we're not done. So all we found was the one dimension. So the one dimension is 85, right? So if this is 85, that means what's the other dimension? There's a couple ways we could figure this out, but let's just use, without doing more calculations, let's just use what's given to us. We know the sum of the three sides has to be 340 feet. So that means these two sides added together is going to be 170 feet, right? So all we have to do is take 340 minus the 170, okay? And that gives us 70. No, I'm sorry. That gives us, that gives us 170. So that means for y is double x. Huh, that's funny. So y is equal to 2 times x in this case. So if we make the length of the parking lot twice the width of the parking lot, in this case, because they give us actual numbers, so the length, or x, whatever you want to call it, x is going to be 85 feet, and y is 170 feet. Okay? And if you add those up, 85 plus 85 is 170. 170 plus 170 is 340, and we get the amount we needed. All right, have a great day.